So, hello everyone. So, good morning for those in Asia, and good evening and afternoon for those in the US. So, today is our second lecture. So, the topic is word problem. So, actually, for word problem, it's something that probably already start to learn in primary school, and definitely you encountered in AMC 8. But word problems are still a very important topic, which occupies lots of percentage in the AMC 10. So now I will show you how many problems show up in this year's AMC 10. So that is other. Everyone, please be on mute. So these are the green ones. So you could see that in each AMC 10 for this year, there are 4 problems which are word problems. So that occupies quite a lot of percentage, right? 4 divided by 25, so that's 16%. Also, you could see that many word problems are easy problems. So the key thing that for us to build up the capacity in solving the word problems is you have to solve the word problems in a relatively smart way so that you can save some time for the later difficult problems. And in the word problems, there's also an important topic, which is to calculate the average. Actually, for this problem 19 is about the average. So for the word problems related to average, we are going to discuss together with the statistics. So today's word problems are mainly something not related to average. And for word problem, probably I know that for many of you that you know that word problems can be solved by equations, and that is the case for most of the problems. But for the word problems appear in the computation, many of them usually have an easy method, which is which is which have no use of the equations. So that's why for the problems that we are discussing today, I'm not going to use any unknowns. I'm not going to use x. So this is means something like we deal with arithmetic. And of course, for the equation part, that's good because that gives you a general way. So in your own practice, whether you are doing the homework or you attend the competition, the method does not matter. Which method fits you, then you just apply for it. But given there are so many textbooks talking about solving the word problems by equations, so today I'm going to tell you more interesting method about using arithmetics. So that is our plan today. So we have two channels. One is Zoom, the other is Xiaoe in WeChat, and both chat rooms have TAs there. One is William, the other is Anthony. So feel free to ask questions and feel free to give comments on the chat. And of course, always try to submit your answer through chat. And for Zoom, please directly message me. Now let's work on problem 1. So that's problem related to ratio and percentage. Okay, cool. I already see some answers in Zoom. Oops, that's nice. And some people already make a comment. So that is a math counts problems. In other words, it means what? It means that's also an AMC8 problems. Yes, this can be regarded as a difficult AMC8 problems, but probably a medium level, like around problem 10 in AMC 10. Okay, but the thing is, so when you private message the answer, you private the answer, you private message the answer to me. But when you have any questions, oh, I forgot to change my display name. And if you have questions, you are feel free to just post to everyone and ask, or you can directly message the TA. Okay, so now roughly I see two types of the answers. One type of the answer is kind of like they make the final, so before the destination, there's a final big trap and they just fall into it. What does that mean? Because they say that the question is asking what? What is the number of cents? And some people give me the amount in dollars. Do not make such kind of like careless mistake. And so I have to see that I do see a few answers. There are definitely correct answers, but correct answers are less than 50%. So right now it's probably only reaches 50% in Zoom. Okay, so now I see a bunch of wrong answers, a wave of wrong answers coming in. So I will give you another minute. I will not release the correct answer for now. So please double check. So I haven't seen any answer. Okay. So I think I'm going to start because I see two correct answers in the Xiaoe system. And for the Zoom, the quickest correct answer from James Wei, and followed by Dylan and James Sun, Stephen Xiang, Kevin Yu, and some others. But still, I think this question will only have about 40% correction rate. So what is the best way to do such questions? So first, after you read, of course, the first step is you read the question maybe one time, and then you notice what? You notice there are three types of screen paste. And so there could be three different brands, but we only care of to find out the quickest way to distinguish them will be which will be the first letter. So bright, F, and then the third type is called G, right? And then while you read it, you notice there are two things that were discussed. One is the price, the other is the volume. So then I will have volume, I will have price. So then we can quickly form a table. And so to make the things here more now we can make things here more organized way to fit every condition in that table. Then that can help us. So bright is 60% more expensive than fresh. And also after you quickly read the question, you'll notice that fresh costs $1 per unit of volume. So maybe we can start would be we just start that the volume of one fresh is 1, and the price is just $1, right? Let me start with there. So that's why sometimes it's better that you first have a quick glance of all the questions. Then you know that you may not start with the first condition, but you start actually in this question. I start with the last condition. Okay, and then I read the first condition. Bright is 60% more expensive than fresh. So bright is 60% more. So $1, so 60% more, of course, is $1.60. So I will start with I'm going to use dollar first, and then we change into cents. And the more expensive than fresh, and 25% less volume than glow. So 25% less volume than glow. But maybe we leave this condition for now as we don't know which part to set. However, we already set the volume for F, so it's better that we wait this condition. Okay, so let's underline it. And then glow is 25% less expensive than bright. So how to calculate this quickly? Of course, the formula should be $1.60 times 1 minus 25%, because 25% cheaper. But the way I do it mentally would be, what 25% is a quarter? How many quarters we have? Within a dollar, we have 4 quarters. So this means, so it's 3 quarters out of 4, right? So each 25% corresponding to 40 cents, so 40 times 3. So you should get $1.20. Okay. So then the price illicit, and then next condition, 33.13% more volume than fresh. So when you see this, what should be your reaction? You should feel happy. This is, let's change it into a fraction, right? This is just 1/3. So 1/3 more volume than fresh. Okay, so now I can do something. So it's 1/3 more, right? So of course it would be just 1 plus 1/3. So 1/3, or if we write as a single fraction, it's 4/3. Right? So that would be the volume. That would be for G, and then we can do the things for what? And it looks like what the calculation is calculating the per unit volume for glow, right? Okay, so now I think we can do it, right? We don't really need this condition, right? So $1.20, and the volume is actually 4/3, and it's asking per unit volume, so it's only the final step. The final step is what? The final step is using $1.20 divided by that volume, which is 4/3. Again, so how to calculate this quickly? So that means, so 3/4, what you are thinking. So you can first mean, it means what? So then it's something over 3. So the idea I look would be this is kind of $1.20. It's kind of like 3 1/3, and then this would be 4 times of that. So then each one has to be 30 cents. And then, so the result will be just 30 times 3. Sorry, I made something wrong. So the idea is, because it's divided by 4 times 3, so you can, what you do is you just divide 4, then you get 30 cents. So I should write. So if we strictly to do that, then that would be this. So we may make it into a multiplication, and then this 120, actually we need to divide it into 4 parts, and then each part would be just 30 cents. And so here, because the whole thing is more than 1 volume, so here we are calculating the volume, 1 volume, so it's just 30 times 3, so it's 90 cents. So 30 times 3, that is 90 cents. So rigorously speaking, I should remove this equal sign. So this is about dollar, this is about cents. So that is question 1. So you'll see that if you use in this calculation, you'll see I try to avoid using the fractions. I try to kind of like divide things into portions. So try to use integers as much as possible. Then among the decimals, fractions, and percentages, these are three types of ways to express a number. You just select the one that you think that is the best for you to do the calculation. So that is problem one, basically a quick review. And now we move on to problem two. So that problem two is essentially an English problem. Okay, so this is like a one sentence English problems. And I think for most of the students in this class, English is your native language, so you should be happy about this question, right? There's only one sentence. Okay. Yes, so our lectures are being recorded, so the playback will be available after the class. Yes, so some TA give a good hint, which is you try to separate the question into the long sentence into different parts. Then it actually will be easier. The other hint is try to draw a picture to illustrate the situation. All right, so I'm going to start giving that both sides. I have seen the correct answer from Liang Zhi as well as from Jason and James. Okay, so how to draw? I'm going to draw a picture. So for the age, so it's a fortunate or unfortunate fact that Leah becomes 1 day older every day. So the way to express an increasing number is we can use a line. So here there are two persons, and given that they both have the initial letter M, so we have to use two letters to denote these two persons. One is MO, the other is ME. So that is what I'm going to do. And then what I'm going to do, I will draw a long line to denote their age. Not one long line and two long lines. Okay, so it's kind of mouse is twice as old as mouse was when mouse was 1/3 as old as mouse one will be when mouse It's as old as ME. So how? So after I read this sentence 3 times, I finally figure out that there are not that many kind of conditions. And so you see this condition as old as ME was when ME was. So essentially, that's mathematically this just means ME was certain number. So as old as MO will be when MO is. So this is also just talking about MO. And then you can have what? You can have the numbers. So here is multiply 2. Here is kind of like 1/3, right? What is here is equal sign. Okay. So now it looks like essentially there are 3 mathematical kind of relationship described here. And they see the age difference of their age is 666. Okay. Then one thing we need to do is we need to figure out and who is older. Actually, from the smelling phase, there's a word called will, and that gives us some idea. So MO will be when he is as old as ME now. So which means what? Which means MO, so this person is younger, right? And then the other person is older. So that's why he need to grow, and in later years, MO will have the same age as ME now. And then now we can start to draw the picture. So ME is a little bit older. So now if it's this age for ME, so what is the age for MO now? It will be a situation like that. And also, then the age difference is 666. We know that this must be 666. Okay. So this condition has been explained. Now what's next? What's next is, okay, so when ME was 1/3 as old as MO will be when MO is as old as 1 ME. So you see, after you read it more carefully, you'll see this is useless. This sentence can be greatly simplified. This just means when ME is 1/3 of his current age, right? Then that means when ME is 1/3, so we have this is 1/3. Okay. Then what is that? MO is twice as old as ME was 1/3. Okay, so this means the current age is twice, right? So this relationship is the twice relationship should be expressed here, right? So twice it means what? It just means, okay, so you from the line segment you can see this will be the double. So you can have a tick here, you can have a tick here. That is 1/3. And then these two ticks are the same because the age difference. So that then should be because this is double, right? So if this whole thing is 1/3 of ME's current age, then there would be another 1/3, right? And ME's current age is what is now. So this 666 would be just 1/3. So that is the thing that we can do. And so it will be 666 divided by 1/3. Of course, that is 666 times 3. So you are maybe not familiar with 666, but for me, is quite familiar as this multiplication will just give the year number, which around the time that I am attending the mathematical computation. So that's the result is 1998. So once you write down the condition in a nice way, especially in a picture, then it becomes a piece of cake. Right? Okay, so that is problem 2. And now let's work on the next topic. And the next topic is also another important thing important tab in word problem, which is 3 that's related to the speed, and given that in order to calculate the speed, we need to have the distance. So within certain time, you travel certain kind of distance, you can measure how fast you are, and then that is the formula. So that is called the distance, time, and speed problems. So there are three kind of variables, and then among these three variables, and then there are some relationships, and the relationships are kind of linked by these three equalities, because essentially they are the same as when you multiply the time on both sides, you get. So all the things start with the definition of the speed. Speed is distance over time, and then you multiply time, you get speed times time is distance, and you switch time and speed, you get the other. And for these things, it's actually related to physics. Why I mention physics? Because so when we're talking about physics, there will be one basic, very important thing would be the unit. So here, how we describe the speed. Normally, I think in US we use that, right? Miles per hour, right? Would be the abbreviation for the expression. Another way to write it, a more mathematical way to write it would be mile divided by hour. So why is that? Because the distance would be measured in miles, and this time would be measured in hours, so that would be mile per hour. While for time is always measured in a certain unit, one unit is hour. While for distance, mile is one kind of unit. So when you work on these things, so sometimes for some weak students in mathematics, what I see is they will add up the speed with the time. But if you know that every number in this type of problem is associated with unit, so you can avoid such silly mistakes. And also, if you deal with all these things in complicated mathematics, actually that can guide you to see which kind of direction you should go for your calculation. So, of course, technically speaking, as in the expressed in the first problems, you need to be careful about the unit so you won't fall into the trap just right before you submit your answer, right? All right, so that's a quick review about the formula. And so now let's talk about that. That is not a problem, that's just like a quick example. I hope everyone of you sees similar ones. So can you type me the answer maybe to everyone quickly? I see, how many correct answers I can get in a minute. Any? I do see some people fall. Some people make mistakes as well, but okay, the majority of the answers are correct. So there's three numbers, right? 100 kilometers, 50 kilometers, 75 kilometers, and so if we think about how these fly will go, it will be something like that, right? So go here and then here and here. Something like it, and then it will kind of converge in the middle. There will be so they will make a tens. This bug must be make tens infinitely many times. If you really use careful calculation to calculate each period, and then it would be difficult. But the smart way would be that they use the same time. Of course, in this scenario, they describe in a very unfortunate situation where two trains together with the fly, clash together. But from this scenario, at least they show what? They show the time traveled by the bug together with the two trains have to be the same. So this is same time condition. It's kind of like a hidden condition in the problem. And in later problem, we'll see there could be hidden condition about same distance, the same speed, this and that. All right, then the same time, what is the time? The time is that, so every train is doing 50 kilometers per hour. Then in 1 hour time, how many miles they travel together? No, kilometers they travel together? It's 100, right? So they will meet in 1 hour. So 1 hour, so the speed of the fly is 75. So kilometers per hour. So 1 hour, so that will be 75 kilometers, right? So that is a correct answer. But I do see a wrong answer, which is 150. Why? Because you directly use 100 kilometers divided by 50, you get 2 hours. That's not right. We have two moving objects that travel toward each other, so we need to add up the speed. All right. So now this would be a fancy question with trains and bridges. So someone saying that in Zoom you cannot hear me. Is that the case, or it's only applied to someone? Okay. So if you cannot hear, my suggestion would be you just quit and rejoin. Most likely it should be fine. Draw a picture. That picture will include bridge, the train. And remember that the train is not a point. Train is kind of like line segment because the train has many, it's very long. Okay, so I haven't seen any submissions yet. Okay, so I'm going to flip the page once with my picture and then flip back. So these are some critical time span that we need to consider. Okay, now I will flip back. Okay, so I think I'm going to start giving that I see both correct answers from the two channels. From Zoom, that is from Andrew Shi, and from from Xiaoe is Brandon Song, and 穿越时空 and Timmy. All right, so now let's see the read the question carefully, and then we flip to the pictures. So the whole thing takes 58 seconds. It means there will be a 50-second period that the train that touches with the bridge. From the head touches bridge to the tail kind of leaves the bridge, right? And then there's a period of 16 seconds that the whole train is on the bridge. So 58, 60, 16. And the bridge is 925 meters. Okay, so now I'm going to flip the page, and before I forget the condition, I will write down that so that now we can work. All right, so these are the situations, right? So there will be four situations. The train head touches bridge, and then the second time, the second special period is the whole train just all on the bridge, and then the train is about to leave the bridge, and the train how they leave the bridge. Okay, so what are these? Then what would be the whole thing 28 seconds, 58 seconds. So 58 seconds would be the whole thing, right? So this whole thing is 58. So what about period where it is 16 seconds? So the 16 seconds would be from here to there, right? So here it would be 16 seconds. Okay, then naturally you need to consider this and that. You know, in mathematics, one reason that mathematics is beautiful is because it has symmetry, right? And from this picture, actually, it has a certain kind of symmetry, right? So from here to there, what is the total distance that the train has traveled? When we consider the distance that the train has traveled, you have to consider in this way, which means you can think yourself just as other driver, other train drivers, right? So you only consider how much distance the train driver moves, right? So it goes from here to here. So the total distance is actually just the train length, right? So I better not write down the word. Just use L, right? The train length L, right? That would be the total distance. Then how about here? It is the same, right? It is also this L. So given the train speed is a constant, so that means this two time period, we should spend the same amount of time. So then how to calculate that? Then that would be 58 minus 16 divided by 2. So we have 42 divided by 2, so that would be 22 seconds, right? So 22 seconds here, 16 seconds here, 22 seconds here, right? And, okay. Then that's a good step. And then what to do next? What to do next is we have to kind of like link the knowledge about the length of the bridge. Okay, so the length of the bridge is what this is called. This is called a distance, right? This is called the distance. So let's analyze what are the conditions we have. So this is called the distance, right? Condition we have. Now all these are the time conditions, right? And the result we get are about the time. So we have time, we have distance, then definitely the third thing would be the speed. The speed is the train. The train has the same speed, or the constant speed, right? So in order to find what we are going to find, what we need to find is the length of the train. That is another distance, right? Meters. So somehow then you should get some sense. Same speed, constant speed. So that would be related to the ratios, right? So the more time the train travels, the more distance it travels, right? Okay, and then this period 22 seconds. They travel for the period of for the distance of just the train length. Then how about by which period it travels the distance of the whole bridge? Be careful, it is not these 16 seconds. Because from 16 seconds it only travels from here to there. It is only part of the train, it's not the whole train. It's actually from here to there. It is the whole distance of the bridge. The way to see it is you can think that at the back of the train there is maybe a cat. Sorry, I never know how to draw a cat. And anyway, so there's some animals here at the back of the train, and then you can see what the total. Then that would be easier to see what the total distance traveled, right? For the train, it's exactly the whole bridge. So now everything is clear. So for these 16 plus 22, which is 38 seconds, we travel the distance of the total bridge, which is what? Which is 925 meters. And then during this 22 seconds period, we travel the distance of the lines of the train. Then what, given that the same speed, so there should be a ratio relationship. So L is just what? It's 925 divided by 30. Did I make some mistake? Yes, I think. I made a numerical mistake.
I think it was supposed to be 21, not 22.
Yes, you are right. So 21, and then here's 21 again. So here we have 21, and then here I have 37. So the thing that you can identify for me. So why until at this stage I figure out my numerical mistake is because I want to do the 925 divided by 38. Then I see some ugly numbers. Then somehow the hint tells me that normally, a mathematical problem is Olympiad problem is beautiful. So there should be some ugly numbers, and so that's why I got to come back and check. So then times 22. And then the result, actually this gives, now 22, that also has to be, we need to change carefully. So 21, so 25 times 21, so it's 525. That is the correct answer. So that is this problem. So I hope, so this problem in a sense is difficult, but if you draw a picture and you analyze step by step, you should be able to figure out a natural way to reach to this solution. All right, now next one. That's again a bridge, but there are more objects involved. There are two people that are working on the bridge. Yes, I see. It's good that some people are talking about my mistake about 21, 22 in Zoom. Yeah. So that's the scenario I could see, although that while I'm explaining the problem, I can now see the Zoom chat. All right, now I do see some quite different numbers. And so there's no answer. So someone complained that this is the AMC 10. So I think in mainland China, this could be like a grade 6 primary school problem, of course, math computation problems. And what I'm going to show you is we do really, there's do really not too much knowledge or kind of techniques required as long as you are kind of like uh, a little bit patient and draw a nice picture. And each step, just analyze these two things, the relationship between the three things: distance, speed, and time. But of course, you need to use that relationship multiple times. Then you should be able to reach the answer. And one thing, there's one trap. Let's get rid of that trap for now. So the train is far times faster than each friend. So 5 times faster. So this it's a good, all it could be that it's a little bit vague. So the train speed would be 6 times. Let me just make it clear. It is not 5 times because it's 5 times faster. So it takes times of the no of each friend. So these two friends have the same speed, right? So the train speed is 6 times the friend speed. That is a key condition. Then of course all the other things are the scenario, like how the the four objects are moving. And it's yes, people in math problems are always kind of like a little bit strange. So it seems that I see one correct answer, but that person changed his answer later on. So then it seems there's no correct answers. So how shall we do? And I'm going to draw a picture. So what are the key conditions? I think this question with the key conditions are simple, right? So the speed ratio is 6 to 1, and altogether the only numerical condition would be what we have, 100-meter railroad, right? 100 meter. Other than that, there's no other conditions. So hopefully you already remember the scenario. So now I'm going to flip into the next blank page, and where I'm going to draw the scenario. So we need to have a bridge. We have a train, and so here I will use this to denote the bridge. And so where's the train? The train I will use this. So here's the train, and the two people. One thing actually, when I first see the question, I'm considering is, when these two persons did make a decision, why so toward this way, the other toward that way. Then the question is, how, whether it's close to that end or close to the other end. Do we have any ideas? But I think for a while I didn't notice any, you know, I didn't really have any ideas. So then probably, I will just, whatever it is, I will do that. But definitely there's one thing. One thing I can be for sure is what? It had not be in the, suppose this is the middle point, right? So these two people must be on this half, right? If the two people on this half, then this guy is so stupid, right? Because he has less time to run, giving the train will first reach that end, but he has longer distance to cover. So this is impossible. So definitely the two people have to be in that range. That's two people. And I'm bad at drawing people, so I have to do that. I will do F1 and F2. These are two people. Right? One is going this direction, the other is going that direction. Okay. And maybe I will just name this train T, and then later on I will just draw a circle. So this is the first scenario. Then what's the second scenario? The second scenario will be that. So where is F2? So this person hit with the train, and then this will be a little bit longer. So that will be F1. Right? So of course there will be a key point, which is this point, and that point is where F1 is when when the other person hit the train. And also, this has a point here, right? So we have to identify what the relationship between these 2 points, and then you do the translation here. You get that. And what you can describe these two, the distance of these 2 line segments, it must be 1 to 1, right? Because the 2 friends have the same speed. So during the same time, they should cover the same distance. Okay, so now this one here, I see 1 to 1. This my green one is just actually means just means a unit. Okay, then what about the train? We saw that the ratio of the speed is 1 to 6. So now we know that this distance would be what? Distance would be 6, right? And so that is part we know. Okay, so now what's the third scenario? The third scenario would be here is the first person, and here is the train. And of course, from this kind of analysis, we already know that our focus would be how long is this part? How long is this part? This part is what? Oh, I hope I change the color. This distance is during from this time period span to that time span, the first person, the distance the first person travels. Then how much distance that the train travels? The train would travel 100 meters, right? So then what would be these 2 ratios? So these 2 ratios also would be 1 to 6, right? So if this is 1 to 6, then the difference would be 5. The 5 is my 2 green units. So what will be the one red one here? It will be 0.4. Okay, so I write down so it's 2. Oh, maybe. So it's 1 plus 1, right? So it's 1 plus 1. What is 1 plus 1? It's this distance divided by 6 minus 1. That gives you 0.2. And that is the speed, that's a distance, right? So the 2 distance have a ratio of 1 to 6. So this will be 5 portions, so they will get 0.4. Okay, and then once we have that, I think we are happy. So this is 0.42, and what the question here calculate here is 6. So we just use 100 meters divided by 2 plus 0.4 times 6. And so 100 divided by 2.4, that is not really a nice number, but 100 times 6 is a nice number. So it's 600 divided by 2.4. 600 divided by 24 is 225, so it's 250. So that would be the answer. So is everyone clear now? Oh, do you see any of my mistakes? Yes, it will be 5 times faster. It will be 6 times. And probably if you do 5 times, you will get a different answer. But I agree that for whether it's 5 times faster or not, that would be a little bit vague in a sense. All right, so now we do a quick review. From these 2 questions, we know that when we consider the meetup problems, we need to calculate the sum of speed, and if we do a chase-up problems, we need to consider the difference of the speed. All right, so now next time is, so we have a huge delay today, and we are still on problem 5, but that is the other speed distance problem. We have two objects. We have the bus. We have the man riding the bike. But all the conditions we have, although it's kind of like speed, time, distance problems, all the conditions we have are time, only minutes. And the question it's asking is also about minutes. Jason, do not type 11 things on the chat channel and block the things. And someone complained that this question is hard. But I have to tell you that in AMC 8, there's a real similar problems which appear as, I think it's problem 25 in 1 year of AMC 8. So try to draw a table. Oh, so there's also something that we need to be careful to be. When they say on his way from Y to X, it does not include the bus that he see at Y and X. It means on the way, not including Y, not including X. Yes, and I think the TA also gives some hint to you. Yeah, the first. Yes, and of course we assume that when they always see the bus that we already passed, meet up with the person. All right, so I'm going to see. So the reason I didn't announce the answer is who got the correct answer is because I haven't remembered the correct answer yet. So what I'm going to do is I'm going to try to do the analysis, and then I hope so through the way I show you how we can do the things in a natural way, even it looks like the hard at the beginning. All right, so here they don't specify the detailed time, right? So then for me, maybe I'm going to specify some detailed time, then that can make my life easier. So what do I see? So maybe we see that when they leave from Y, to X, when he starts from Y, so he just starts at 8 a.m. Like when our course starts in Hong Kong, right? 8 a.m. And then what would be the situation? He see 10 buses traveling towards him, where he arrives at X. So every 5 minutes, there's a bus leaving from X. So one thing that we are not sure is, so we have to see this will meet the first zero, the bus number 0, right? So this is at station Y, and we meet bus number 0, right? Because this bus does not count as the 10 bus. The one thing you may think is, okay, so at 8 a.m. I meet this bus. Then what will be the next time I meet? So it must be 8 something, but is it 8:05? Would be 8:05, or it would be a different time. If you think carefully, I'm not going to draw a picture, but just think carefully. Suppose I am the person who is riding the back, and then this is station Y. So that means what? So around that point, there's another bus that is 5 minutes away from me, right? Because the interval between every bus is 5 minutes. However, then during once I start to travel, the bus will travel as well. So for me to meet the bus, even I ride back, I ride very relatively slow. So for me to ride the bus, it will take less than 5 minutes, right? So in that sense, we don't really know exactly the meet time. So that is the part which is difficult, right? So you can see maybe around this route that you get stuff. But actually, what is kind of like this scenario? If you analyze a little bit, so analyze a little bit, because when you think this way, you always think away from this person, right? From this person, or in other words, you are thinking about the meetup time. Then you have trouble. Now, how about we do an easy thing? What's easy thing? Is we just think about the bus. The bus goes from X to Y. Let's just think about the bus. And the bus, what happens? The bus will be 8, right? At 8 a.m. at 8, they reach destination Y. When did it start? So it must be started at 7:45, right? So because it's 15 minutes. The whole distance is 15 minutes. And then we know that this would be our bus number 0, right? Okay, then what's next? The bus number 1 must start at 7:50 and arrive destination Y at 8:05. So that would be number 1 bus. Okay, then I think we have a relatively easy life now, right? What's next? We need to consider number 10 bus, right? So number 10 bus would be easy, and then also we need to have the number 11 bus, which is that this is related to so for that number 11 bus, that is related to the guy that meet at X, right? So this would be what? So maybe I will, now I'm going to check the answers and see if I can get something. All right, so now I do see some correct answers on the Zoom, and which are in Zoom, the first correct answer from Michelle Hu, and followed by Kathleen. These are the 2 correct answers, and in Xiaoe it's 2只蛙. Okay, so each time we add up 5 minutes, so we need to add up 5. So there's 11 buses, so we have to add up what? We need to add up sorry. So I think no. So that would be 8:55, right? So 8:55. So that would be 11 buses, right? And then what is the starting time? The starting time is just 8:40. So it's at 8:40 to 8:55. So that would be the time that this guy reaches the destination X, right? So then what would be the total distance? So that would be actually, so I think that would be actually 40 minutes, right? Sorry, I think the correct answer should be from Megan and Shu Ying Liu. That should be the correct answer because they start at 8 a.m. and they finish at 8:40. So if we write down a one-line formula, it would be altogether we meet up 10 buses plus last bus. So it would be 10 plus 1 times 5, then minus the 15 minutes total distance. So the answer would be 40. So that is problem 5. All right, so now we have passed the most difficult speed, time, and distance problems, and we are going to do something relatively easy. So that is problem 6. It's related to some work. So we do a work, and there are some people involved in it, and we do it. Okay, so it's good that I see many answers, and then in this time, definitely the correct answer, dominant both sides. Okay, so what is the quickest way to do it? But I do want to show you, I know there's some standard way which assume that the whole work is 1 unit, but I do want to show you some quicker methods so that we can really calculate mentally and finish it. So I'm going to use the example of 西游记, right? So this we have a master, we have a senior apprentice, and junior apprentice. Okay. So what is the best way to do it? So suppose Sha He is doing this problem. So what he is thinking, or what he should think, is that total workload is not 1. I will assume the total workload is 120. Why is that? Because 120 is a number that I see immediately, which is a multiple 10, a multiple 12, and a multiple 15. Let's see that we need to get 120 pitches right for dinner. And then it takes 10 hours to finish, right? So what would be the the kind of like the speed and then the work that we can finish per hour. So that will be 12. 120 divided by 10, that is 12. And then 120 divided by 12, that is 10. 120 divided by 15, that is 8. Now, this would be the work capacity of these 3 people, but everyone appear twice, right? So we need to divide it, add up them together, and then divide it by 2. So 20 plus 10, 30, 30 divided by 2, 15. And then what would be the last step? So the last step is we just use 120 divided by 15. We get 8 hours finished. So that would really be a 1-minute problem, right? So if one day I will participate in the design of AMC 10, I will put that just problem 6 of AMC 10. Because if you use the idea of using the integers, assume that the total workload is not 1 but 120, all the calculations are fairly easy. Right? So that is why that I put the problems here. So try to use integers as much as possible. In many cases, do not assume that it's 1 unit, but assume some big numbers. All right, problem 7. And that question has other different type of techniques. Yes, some people just ask why I do not select 60. Yes, 60 works as well. But for me, I want 120 because that's already, we do not really need to find the least common multiple of that 10, 12, 15. As long as we find some good numbers, then it works. Any answers? So I see 3 different answers. Okay, so I see 4 answers. 2 of them are the same from 2 channels. And I would assume that to be the correct answer. Let's see. Right. Okay, so first maybe we quickly read that problem to see how many steps are there. Originally they have 145 candidates in total, so that is the first condition. And the first And the first action is Lam gives half of his candies to Ricky. So that is the first action. What is the second action? The second action is Ricky also gives half to his candies to Ollie. This is the second condition. And the third condition is Ricky and Ollie each eat 29 candies. Okay, so third candid action. The first action is Ollie gives 20 candies to Lam. That is a first condition. And then what is the last condition? The last condition says that this is not action, but it's condition. That eventually they have the same number of candies. So we have four actions. At the beginning, there are 145 candies. In the end, everyone has the same number of candies. And then, of course, you need to be careful that in the end, how many candies are there? In the end, there are not 145 candies. There are less candies. So it's be 145 because each of them eat 29. So minus 29 times 2. So that would be 58. So 145 minus 58. So that would be 87. So we have 87 candies left in the end. Given that 87 candies left in the end, then what would be the beginning thing? What would be each person get? That would 87 divided by 3, so that is 29, right? So everyone has 29 candies in the end. So what we can draw is we can then draw a table, right? So O, L, R. So in the end, everyone has 29. So we write down as 29, 29, 29. And we know there are 4 steps of actions. So this would be after action 4, right? So after action 4, we have 29 candies for each person. So before that, what happens? Ollie gives 20 candies to Lam. So Ollie should have more before this action. So should be 49, right? Because he gave out 20. And then to the Lam, actually, he only have 9. And then that is 29. So that is step 4. Now we consider action 3. The action 3 is what? Ricky and Ollie each ate 29. So we need to add up the 29 back. So Ollie is 29. So 29 plus 49. So that would be 78. 29 plus 9. That would be 38. And then 29. So that is the third action. How about the second action? The second action is Ricky also gives half of his candies to Ollie. So Ricky gives half to Ollie. So that means originally he have 29 doubled. It's 58. Lam is still 38. So this will be minus 29. So he gets 49. Okay. So then what's the first action? The first action would be Lam gives half of his candies to Ricky. So Lam gave half of his candies to Ricky. Now he only have 38. So what would be the situation? So that means he originally have 76. So Ricky have 38 minus 58 minus 38. So Ricky has 20. And Ollie still have 49. So that would be the... Oh, I made some mistake again. Ricky ate 29 candies, not Lam. Okay. I see. Oh. So Ricky ate 29 candies, so we have to add up 29. So 58 and 9. And the step 2 is Ricky also give half of his candies to Ollie. So that would be still... Step 2, Ricky also gives half of his candies to Ollie. So in the end, he should have 116. And So that is 58, so that he's 20, and he's 9. And in the first step, is Lam gives half of his candies to Ricky. So originally he had 18, so this will be minus y, so 107, and that is 20. So 107 is the correct answer. So it's good that, and so in the first few submissions, many of you get the correct answers. The quickest one are from Kaining Zhang, Steven Xiang, Harry Lu, Maggie Wang, and Jason Shi. And on the other side, we have 穿越时空, Benny Song, Timmy, Wang Qing, and Liang Zhi got the correct answer. That's problem 7. All right, so now we are near 1/2 but we are going to miss one problem. So we have 2 problems to discuss. Finally, it will be problem 9 and problem 10. And for problem 8, I will explain during the homework solutions. So both problem 9 and actually the problem 10 we are going to discuss also related to something that we have to deal with the integer in a nice way. So in mathematics, something that we only deal with integers are called discrete mathematics. The difficult part in here is that all these people keep relaxing, and they're relaxing at a different frequency. So I see some answers are quite close, or maybe correct. So we need to have some ideas, right? So roughly speaking, right? So if they never rest, so they will make 2 toys per minute. So that needs 150 minutes. So the answer has to be definitely greater than 150. So if you give some answers below that, then it must be wrong. And also, you should have some sense that even they don't rest that often. So the answer should be at least, averagely speaking, they should be able to make at least 1 toy per minute. So the answer also has to be less than 300. So whatever the answer you get probably has to be between 150 and 300. So if you get something by whatever the calculation, you get some numbers, which what I see, some of you give me a very large number, then you have to know that it must be wrong, right? So if you give me a number is 200 or 210, it's hard to judge which one is correct. So that is called a ballpark, sanity check. All right, so given the time is limited, so I'm going to explain, and then I will check back who get the correct answer this time. And also, hopefully, I will not make any silly mistakes while explaining. Okay, so what is the idea? The idea is I draw a picture, always draw a line diagram to show what the situation. Lee needs 1 minute break for relaxing for 3 minutes. So what the situation would be something like that, right? So every 4 minutes he work, and then he rests for 1 minute. And then what's next? Then this thing continues. But for Zoe, the situation is a little bit complicated because to save some energy for me, so I'm going to just continue to write in this picture. So this will be rest for 1.5 minutes after making 4 toys. So I have to extend this kind of picture a little bit longer. There's many units here. Anyway. Okay, so he would rest for 1.5 minutes and then he will continue. So the situation would look like what? He rests and then he work, but this time, he work kind of like from half minutes to another next half minutes, right? Until he rests again. So altogether there should be 9 minutes, right? And then we just continue, right? 1, 2, 3, half, and then 1, 2, so this 1, 2, 3, 4. 1, 2, 3, 4, and then rest. And then rest. So it seems that we still don't have enough space, so I have to continue this pattern. And then for this, I need to do 1, 2, 3, rest, 1, 2, 3, rest, 1, 2, 3, rest, and so on. Okay, so we will see that when this kind of pattern can be repeated. So let's do some calculation. So here is 4 minutes as a period, 3 plus 1. Then the other one is 4.1, 4 plus 1.5 is 5.5. Then what would be a common multiple of 4 and 5.5? The first thing you think would be 22, right? So 22 is just 4 times, but this is not a full period. It's 5 times 5 period. But for 5.5, of course, it's a full period, 4 periods. So we better consider what? We better consider double it. So we consider every 44 minutes. Then in every 44 minutes, what's the situation? For Lee, he has 11 period. During this 11 period, he can produce 11 times 3, so that is 33 toys. Then how about Zoe? Zoe is 5.5, so there are 8 periods, and each period he could produce 4 toys, so that is 32. Now 33 plus 32, so altogether that would be 65. Okay, then we can do some deduction which from this 300, and we see how many situations are there. That would be 300 equals what? Equals 65 times what? You see our times 5, but times 5 is too many. It's 325. So maybe we just times 4 and then plus 40, right? Okay, so now you have some rough idea. So 40. So this is 65. So it's about 2/3 of the period. Of course, one thing is you just write down the whole 44 minutes, like in my way. But for me, I probably want only to write down half. So for half, that would be 22 minutes. So let's try to label it. So that would be 10 minutes. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So that will be 20. So that's what I'm going to do, and I will show you why I do this. So 16. All right. 1, 2, 3, 4, 5. Yes. And so on, right? And so here it is the full period. So 4 plus 1.5, and then 1, 2, 3, 4 plus 1.5, 5.5. That should be 40. 1, 2, 3, 4. I made something mistake again. What is that? Okay. So this would be 4, 4. So here should be, that should be 10. And so that my picture is correct, but my label is wrong. So this would be 10. This would be, I need to make the label correct. So this would be 10. And this would be 20. And this would be 22. Okay. So this would be my half period of that 44 minutes. And then we can count during this half period how many toys we have manufactured. So that would be 1, 2, 3, 4, 5, 3 times 5. So already have 17. And then here you have 16. Right? And then altogether in this first semi-period, you already have 33 toys made. So then what's next? Then what's next is you only to see what is the next time that you already have, how many toys we have? We need to have 7 toys, right? For the 7 toys, now we can, maybe I change the red color to see, because that would be the exact moment. So we need to create 7. So here we have 1, 2, 3, and then 1, 2, 3, 4. Wonderful. So add up another 4 minutes, then we can exactly create 7 toys. So what would be the answer? We have 4 periods, so that would be 44 times 4 plus 22 plus the other 4 minutes. And so the result would be 176 plus 26, that is 202. So let's see how many of you get the correct answer. Before that, I think before I start, I do see I get the correct answer from Michael, from Kathleen, and from Jason Shi, and what else? Yeah, so I think that's about in Zoom. And in Xiaohe, I do not see. I see some answers close to 200, but not 200. Okay, so that is problem 9. Finally, hopefully we will use 5 minutes. Sorry for the delay, and we finish our problem 10. And this problem 10 is not really a mathematical computation problem. And so this is an entrance exam to become the government employee in China after you get your bachelor degree. So in a sense, this problem should be simple. Well, someone get a nice answer, but it's not a correct answer. So this is really a kind of like the optimization problem, right? So the idea is, if you look at the numbers, definitely what the situation happens is, so all of them can create more pants because so when you prepare a set of suits, right? Definitely it's more complicated to create jackets. So they can all prepare more, produce more pants than jackets. So by that observation, so you should have built some idea that you could probably make slightly less than two people working on pants, and then slightly more than two people working on jackets. So, and also you can do some you can do some sanity check, right? And how large would be this number? So roughly, we can create 10 pens per day, and we can allocate two people to prepare pens, right? So the numbers would be roughly, at most probably 140, because 20 pens per day, 7 days a week, so 140. So if you get some numbers much bigger than that, then that must be wrong. So it's nice that I see some answers like 120. So 120 is the mode of the currently submitted all the answers. So I will see that 120 is a nice design, but 120 is not the best. So for those of you who ever get 120 or slightly below 120, now let us see what would be the best design. And so here, and it shows that we really need to use some mathematics, and that mathematics would be the ratio. So the ratio, I will define this ratio as J over P. So let's do that ratio first. 8 over 10 is what? It's 0.8. What is 9 over 12? Is this 0.75? So this is 0.80. So what is 7 over 11? Do you do you have your capacity on repeating decimals? You remember there's one problem in AMC 10 this year is about repeating decimals. So make sure that you understand the repeating decimals for all these small denominators. 1 over 11 is 0.09 repeated, 0.09 times 763. So that will be 0.63 repeated, so that's 0.63. And then what is 6 over 7? 6 over 7 would be the each period of the repeating decimal would be a permutation of 1, 4, 2, 8, 5, 7. So this 6 over 7 starts with 8, so it will be 0.84. No, this should be 85. Because it's repeating 85. 7, 1, 2, 1, 4, 2, right? Repeated, right? Okay, so anyway, now but here, what we need to have is we need to observe the ratio. So they have a ranking, right? From small to large will be R, K, D, W, right? So what does it mean? It means that for those of you who has a large number, relatively large decimal means they'd better produce what? They'd better produce jackets, right? Because they have more efficiency in producing jackets. So by that way, then we naturally have an allocation. The allocation would be P. W is definitely produce jackets, and the same for Daniel. And then how many jackets we can produce? And so it looks like, so ideal way it would be we make them to produce pants, right? And then let's see how many, then in this scenario, how many jackets we can have. So how many jackets we can have would be 8 plus 6 times 7, so that is 98. So that would be the number of jackets. But of course, you cannot let all of them, only these two people producing jackets. So there has to be one person that prepare jackets as well. Then among these two, among K and R, who has better efficiency in producing jackets? It should be K, right? Because it's 0.75. So we should let Carrie provide some jackets as well. Then that means for the pants, the first one thing for sure is only this 11. So for the pants, we only have 11 plus 7 equals 77 to start with. But then the key thing is how we allocate the work arrangement, how we allocate jackets and pants to carry, to make. So then we could have a little try, and this try will tell you that if you let Carrie create jackets for 3 days, then they get another 27 jackets, and then you let him produce pants for another 4 days, then that would be give 48 pants. And altogether, no matter what, you get 125. So now you can prepare 125 sets. So that would be the answer to this question. So this is the ideal design. All right, so now we finish discussing our kind of like non-standard word problems, and hopefully that you can learn something, learn some techniques, which I summarize here, and there could be other experience that you can draw from today's lesson, and so try to avoid to fall into the trap. Be careful reading about the unit, and be careful, don't make numerical mistakes as I did in some problems. And so that is this one. And so we just want to iterate our course structure. So every week, in addition to the current live lecture, we also have homeworks. And every week we have 20 homework problems, and we also have TA sessions. So we encourage you to attend the last lecture as well as at least one of the TA sessions. And also, of course, we have, or maybe your parents have a WeChat group. And if you have any questions, feel free to ask. If you don't want to type, you can just leave a voice message in the WeChat group, or you can ask TA directly in the TA session. So that's all for today, and thanks for your focus, and we are going to meet again in 7 days. Goodbye for now.